An interesting question on the Q&A site about collision detection, and I thought this was a good chance to make a little sketch that shows some of the things we talked about in respect of object-oriented programming, creating your own classes and using your own objects in your sketches. So I've made a little sketch here that when you run it, it gives you a canvas, and on the canvas you've got one circle that follows the mouse cursor and then another one which is a target. And if you get to the target and hold your mouse over there for a minimum amount of time, it turns red and then the target shifts and you get a point, and you can play this wonderful game where you get lots of points. Oh, it's so engrossing. Anyway, let's see how it looks. So this is doing some simple collision detection, as you can see. Now I've written this in a kind of a, how would I say, a sort of a naive way, using the techniques that we've covered in the class in the first 6 or 7 weeks. Maybe naive is the wrong word. What you would say is it's a procedural way. It's not making any use of our own objects to tidy things up. So if you look through the code, you can see that there's variables to keep track of the mouse, X, Y, and diameter and color, and then also the highlight color, and then the same for the target. There's the target X, Y, diameter, and color. We set up the page, and then we're just setting the target circle to a random position with this function that I defined. Let's just look at the draw loop first. On each draw loop we clear the background, draw the points to the screen, and then update the position of the mouse circle so that it follows the mouse each time. Then we draw the target circle because that stays still each time. And then we have a function here, isMouseOverTarget. Now this function returns true if the mouse is over the target, false otherwise. So we can use this for our collision detection. So if it is over the target, we draw there's another function here to draw the mouse circle in a highlighted mode, so we draw it red, and we record that it's been touching for a certain amount of time. Otherwise we just draw the normal black mouse circle. Finally, on the draw loop, we check whether the number of frames that it's been touching is greater than the frames it has to be touching before you get a point. So you have to hold the mouse over for a little bit of time before you'll get a point. So you can see that here. If I just go, well, it goes very fast. Let me make the time required a little bit higher. I'll set this to 100. So now it has to stay over the mouse for 100 frames before you get a point. So it's over, but you're not getting any points. And then on that last one I stayed just long enough to get the point. And same there. Right. So you have to stay over it for a minimum amount of time. And if we have been over for that amount of time, we increase the number of points that the person has, and we move the target circle to a new location using this function, and reset the number of frames that it's been touching. Let's just look at these functions that I've defined as well. So there's one to update the mouse circle, and it's just simply setting the X and Y position to follow the mouse X and Y. This is the one to move the target circle to a new random position, so it's changing the target circle X, Y diameter to new random variables, and it's also setting the color to a new random color. And these are the ones to draw the mouse circle and the target circle. So there's a function for drawing the mouse circle in its normal color, and there's one for drawing it with the highlighted color. Then there's also one for drawing the target circle in its color. Right, so all of that is kind of housekeeping stuff. I guess for collision detection, this is what you might be interested in. So this is a very simple function that tests whether two circles are overlapping. So the function is going to return a boolean, a true-false value, and its name is isMouseOverTarget. So I can say if isMouseOverTarget, round brackets, and that's going to return true or false. So I can use that in an if statement, for example. Firstly, to do this, I figure out the distance between the 2 points, so I use the dist function, which is provided by processing as a standard function, and I just give that the x, y of the first point and the x, y of the second point, and it returns the angular distance between them. Then I need to sort of think about, well, what's the minimum distance between 2 points before they're sort of touching? And if I kind of sketch it out here, if I have a circle with a given radius and then another one with a given radius, the minimum point at which they start touching is going to be the point where these two radiuses are touching. So as it gets closer and closer, that point there, when the two radiuses overlap, that's when they'll start touching. So the touching distance is going to be half the diameter, which is the radius, plus half the diameter. So that the sum of the two radiuses of the circles. And then to return a Boolean, I can just say return whether the distance between is less than or equal to the touching distance. And this works fine. As you can see, my game works, you get points, the target moves, and it's very challenging. But there's a much easier way to do this. Now, I think if we look through this code, you can see that there's a lot of repetition in the code. There's repetition in the names and the types of the variables that we've got, and there's repetition in the functions that we've defined. And these are clues that we could do it maybe a little bit easier for ourselves if we used objects. So here we've got mouse circle X, mouse circle Y. We've got target circle X, target circle Y. Both these sets of variables are referring to these two circles, and there's a lot of commonality between them. They have an XY position and a radius, and a color. Now that's a strong hint that we could define a circle object, say, and store that information inside it. Similarly, with the functions that I've defined, we've got one function to update the mouse circle position and then another one to move the target circle. And these are quite similar. They're changing the XY position. This one's doing a little bit of extra work to move the diameter and the color. But if you look at the draw functions, these are very, very similar. So we're filling with the color for that circle and then drawing an ellipse using the variables for that circle in each case. And these two, even though they're working on the same mouse, the only thing that's sort of different, working on the same circle, the only thing that's different is this highlight color. And again, like if you see anywhere in your code where the functions are more or less copy and pasted with just one or two minor differences, then it's a clue that you could find a better way of structuring your code. And ultimately it'll make your life easier. Alright, let's start working through turning this into a more object-oriented version. I'll stop this video here and then I'll make another version where I come back and change it into objects.